We are here today to talk about Alteia. Hello and welcome so much to our session. We are going to be talking with Baptiste Rivard and Iga Stockenberger to introduce you to how Alteia and World Bank have utilized machine learning to improve quality of life and invest in areas around the world where we need to improve road infrastructure using geospatial data and machine learning. I am really excited to have them here with me today. We will be doing a fireside chat, and so I encourage you all, if you have your mobile phones available and you have the AWS app for the event, you can utilize this, or you'll be able to utilize the web page and a code. So get your apps ready, and we will kick off. So the way in which we're going to be doing this is we're going to be having introductions from Iga and Baptiste on themselves and the organizations, and then we'll move into a fireside chat. So I'd love to welcome Iga to come up and speak about what you're doing, and you can... There you go.
This one? Go
Yep.
This one?
That one.
Good morning, everyone. So first, I would like to just introduce the World Bank a little bit for those of you who are not familiar. Oops. Is this Go back. Sorry.
It's lucky it's not live demo yet.
So it's the World Bank is the largest multilateral development bank globally, and we lend over $70 billion every year to developing countries that range from low-income, fragile countries to countries that have already reached high-income status but continue to need our help in certain technical aspects or sectors. So infrastructure accounts for about 1/4 of all World Bank lending, and so that includes roads, urban transport, energy and extractives, and digital development. Why do we build roads? We have built over 260,000 kilometers of roads in the last 20 years, which is more than what we lend to education, schooling, and social services combined. But of course, roads are not an end in itself. We help countries build and rehabilitate roads so that people can access opportunities, markets, jobs. From impact evaluations and experience that we have in a range of countries, we know that with improved connectivity, we help farmers move from subsistence agriculture to market production. We help improve human capital outcomes, and we help improve gender equality. I think I'm going to move on. So one thing that we need when we work with countries, both on investment lending operations and also in various types of knowledge products, ranging from local knowledge products to global studies and statistical analyses, econometric studies, impact evaluations, we always need high-quality data. We need to know at the scale of a whole country, where are the roads, how many kilometers of roads there are, so have a sense of the quantity of the networks. We need to know which one of those roads are paved or unpaved, and which one of those paved roads are in good condition or poor condition. So in other words, have a sense of the quality of the network. And this is important because in many times we really have only a very small envelope of public resources that we need to be able to prioritize. We need to be able to tell our clients, which are the country governments, which roads would be, where would be the biggest bang for the buck in terms of development outcomes. And so that means understanding improving which roads will reduce isolation of communities, where improved roads will reduce vulnerability to climate risks, and in other words, we need to be able to prioritize public resources efficiently. So all of that said, we need data. We need data of good quality on the road networks, and we usually tend to lack that kind of data. Even in our most sophisticated countries, we don't have that kind of data, either at the scale we need or the recency we need. And so given this issue, we basically turned to AWS to be able to address the need for data at the scale that we need.
Beautiful, thank you. So I think before we go and talk about Alteia, and I introduce you to Baptiste and Alteia, it'd be really interesting to understand everybody's view on how we went about doing this and understanding World Bank. So let's kick off with our first polling question, which is, which country was World Bank's first client? So if you get your mobile phones out, you can scan the QR code, and it will take you to your app, and then you can select the different options. And if you don't have the app, then you can go to the website and type in the code as well. Let's check what results are coming in. Ah, amazing. It seems you all know the answer. The answer is absolutely France. So World Bank's first client was France. And we won't be talking about France and the use case today. We'll be talking about different areas of the world. But it's really helpful to understand where you started and how you've been on that journey. So let's move on. Baptiste, do you want to come up and give a few minutes on what you're doing and who you are? Let me move on for you. There you go.
Thank you, Claire, and very excited to be here. And knowing that we were the first client of the World Bank means a lot. Before I dig into what we do at Alteia, I'd like to go back to the origin of what we're doing. So most of the core key people at Alteia, we come from a drone commercial background. And in a pre-COVID world, like 10 years ago, we used to be like about the first ones selling commercial drones to many different kind of organizations, ranging from agriculture, construction, mining. And so, we were like really interested in understanding how to scale drone operations for those companies. And when we would ask questions on how they were using drones and leveraging the data, it appears that to transfer the data from site to the headquarters or to other places, they would put all the images collected by the drones on hard drives and ship the hard drives with delivery trucks. So FedEx and UPS were basically the mean of connecting people with the data. And so I guess we had kind of that epiphany moment where we were so proud of working on autonomous technology with such a high level of advanced AI within our drones, and at the same time, relying on delivery trucks to cover the data flow. And that's kind of how we envision starting like Alteia, and the convergence of progress in the connectivity world, and also the rise of cloud technology. All of that led to have today a software platform that's called Ether that does three things, and actually does it, I think, pretty well. Work on data ingestion, so we take visual content coming from different kind of sources, ranging from large-scale satellites to smartphones. And so we have those data ingestion pipelines that cover the whole contextualization process. And then we offer like a user interface to visualize that data, interact with that data, and share that data, along with some smart storage capabilities. And finally, we have a layer of artificial intelligence that is used to extract the content from that raw data and deliver predictions, insights to the business that is then easily shareable between like all the stakeholders of a project. And so on top of that software platform, that's basically like all the technology blocks to manage visual data and artificial intelligence at scale, we build specific applications for specific partners, like the one we do with the World Bank. And I'm going to run a demo on that application so you understand a bit more, what are the outputs that we produce. So what you can see on the screen is the user interface of the application that we've built. The different colors that you see on the map are the vectorized roads that we extract from different kind of images, and I'll go to that in the next slide. And what you can see is it's super easy to interact with the digital twin of the road network model. And by clicking on every section of the road network, from highways to super rural roads, you get actually specific attributes, the type of road, so if it's a paved road or if it's unpaved, and also the quality index of the road. So basically, it's the condition, if it's in a poor shape or, at the contrary, in an excellent shape. And that information, it's actually pretty interesting because it's accessible from a smartphone, from a computer, from the field, from headquarters. And suddenly, you create a bridge between all the project stakeholders and the data, knowing also that we have availability to retrieve all the raw data directly from that user interface. So suddenly, in a click, you access like terabytes and terabytes of data. And I'm done with my introduction, I think. Thank you, Claire.
Thank you very much. That's really great to see it. And ultimately, what I love about this is that geospatial data is there to enable decision-making about where to do things or where improvements need to be made. And yeah, and this is a really great example of that. So we're going to move into a fireside chat now and talk through the different elements of this project and how we went about achieving it. So we will move on to that. So, Aiga, you talked about the importance of roads and why identifying the condition of roads is really important for enabling World Bank to help organizations and clients around the world. Can you talk to us a little bit about why that's so important?
Sure. So we basically have different use cases for this kind of work. So it's, as I mentioned, in general, the condition of infrastructure is very important to understand for us to be able to prioritize public resources. But in terms of the kind of applications that we're talking about specifically in this work with Alteia, I can just mention the case of Peru, where we are working with the government to help implement the next, or design and implement the next very ambitious rural roads program. And so Peru, if some of you are familiar, it's a country of about 30 million people. It's very diverse topography. It has made a lot of progress in reducing poverty, but it still has a lot of territorial disparities in incomes, and a lot of that has to do with inequality and infrastructure quality. And so, and Peru is also very vulnerable to climate risks, which, as I mentioned, is something that we have to consider when we prioritize road investments. And so, having roads that are unpaved in poor condition is, overlaying that with climate risk is a powerful prioritization tool for us to know where we should go and invest. And so, in the past few months and going forward, we're basically working with the Peruvian government to help identify about a couple of hundred roads they should invest in from a pre-prioritized list of about 20,000 roads, which is obviously not feasible for an individual investment program. And so we needed basically tools to help to narrow down from those 20,000 to something more manageable, so that we can start the implementation of the priorities, and so we turned to the big data solutions and ML to help in that process.
Amazing, thank you. You talked about the importance of climate sustainability and identifying these for the roads. So I think this is a really great time to move on to our next poll. So if you get your apps out and open them up and point to the QR code, then let's do a poll on what share of World Bank projects today include interventions relating to climate resilience or decarbonisation. What I love about this too is that World Bank's vision statement is about improving essentially quality of life and doing it in a climate sustainable way.
Exactly. It's the new vision statement as of this year is not only to reduce poverty and improve shared prosperity, but to do so also on a livable planet. That's a key addition this year.
I think it's a beautifully worded vision statement. So do we want to bring up the results, please? Oh, interesting. Fabulous. So Unfortunately, it's not 50%. For those people who selected it, it's actually over 90%. It's an incredible amount of projects that are relating to climate resilience. I think it's an incredible use of resource. And I'm really excited to be able to have worked on this project with you relating to road conditions and climate resilience. So Iga, you, can we move back to the slides as well, please? Thank you. Iga, you talked, I'm going to go back to that one, sorry, having a technical issue there. So you talked about the challenge of identifying roads to target climate resilience. And I'd love to know a little bit more about what those challenges are and how you went about them.
So basically, it's the World Bank. We're sort of helping. We're kind of a technical partner and a financial partner for client governments who are managing the actual project prioritization and implementation process. And so usually the way we go about identifying priorities is through visual inspection methods, which literally driving through the road with a camera or similar device and recording the condition, and then geocoding that and identifying where the roads are that are in poor condition. And of course, this is very time-consuming and can take years and years to do this. And it also is sometimes prone to human error and can be unaffordable or not safe in certain parts of countries. So in the case of Peru and another use case which we worked on with Alteia is Mexico, a slightly different one. We considered the use of visual inspection methods, but and this was not feasible with the budget that we had. There's other solutions, for instance, high-resolution satellite imagery, which is also something that the World Bank is increasingly considering. But again, the kind of budget we're talking about, which is usually less than $100,000 to do that kind of preliminary assessment, it's really not feasible at the scale of a country to use high-resolution imagery only. So this is kind of the inspiration for turning to something more creative, but based on free data and a clever combination of that data and analysis to be able to extract the kind of information we needed.
Thank you. And you talked as well about, we've been working on this in Peru and Mexico, so 2 locations.
So yeah, just a little bit about the Mexico case. It's just to give you a sense of the kinds of applications of this type of results that we got from the work with Alteia. So the Mexico case is slightly different than Peru, where we are working on a more technical advisory activity, not an investment project, to help the government create a asset recycling strategy. So that what that means is basically help understand how they can use their existing road assets, like federal and state level roads, to generate revenue. So this, you can think of like a toll road, but there are many other ways to recycle those assets. And obviously what you first need to know is what is the condition of those assets. And even a country, the sophistication of Mexico, doesn't have a geospatial shapefile of their road network with a condition assessment. And so this was kind of a different use case, but it's just to illustrate that we have that kind of problem with data in every country we work in, pretty much.
Yeah, and it surprises me how many countries don't have good data quality for their addresses or their roads or any of the other assets that they utilize every single day. So what were the options that you explored to enable this decision making?
So like I mentioned, it's really the typical manual inspection, which is we can always go and do that later in project implementation or prioritization. So just as a caveat, the work we're talking about here is really like a high-level prioritization tool that we need at the early stages of prioritization. So we can go and say, these are the roads that we know are poor, or we know that we need more ground surveys to actually really know what's going on. But later on in the project preparation process, we will still go and do more detailed engineering analyses, of course. So basically, it's the visual inspection methods. It's the drone surveys are actually another option that we can consider, and we've done that in places like, island countries. We've done it in Zanzibar, in several other places where it makes sense. But it didn't make sense at the scale of a whole country of Peru or Mexico, where we're talking about 500,000 kilometers. We wanted to find a solution that was remote, but also more efficient and affordable.
Yeah, it's not cost effective or time effective in order to do it at that scale. It works well for small locations, maybe even towns, but definitely not at the scale that we're talking about here. So brilliant, thank you. You've used various different methods and you talked about different data types. It'd be really interesting to understand what were the different data types and how did you approach this with the various different methods?
Stu?
I think I can cover that, Claire.
Thank you.
We've kind of talked through like the data cost and everything, so I'm going to go to the weeds of the technical implementation of the project. So IGA gave us a very complex project to solve, and we had to be wise on how we would, instruct that project. And we've touched already like the publicly available data versus paying information. What we did was rely mostly on 3 types of big data. Most of them available through the Open Data Registry on AWS. And I'm going to spend a minute to explain what those data types are. So first of all, we used optical data from a constellation of satellites called Sentinel. Basically, optical data, what is it? It's the same kind of images that you would collect with your smartphone. So it really looks like a photograph, but taken from space with a resolution of 10 meters per pixel. It means that if you take a pixel, each corner of each corner of the pixel would be like 10 meters. So that was the first data type that we've used. Then we've leveraged SAR information. So maybe for people familiar with remote sensing, you know what it is. For other people, I'm going to explain it. So SAR, it's radar. It's basically electromagnetic sensors that you put on a satellite that throws waves at the Earth and measure, the bounce back of the signal to understand, 2 things. The topography of the terrain and kind of the moisture of the terrain. And SAR is widely used for restoration management or for some topography projects. And as the optical data, SAR has the resolution, or at least publicly available SAR, has a resolution of like 10 to 20 meters per pixel. And so you understand that with that level of accuracy, which is not that great, it would be complicated to make predictions. So basically what we did was enrich that information coming from remote sensing with many different types of databases that are open source that would allow us to create first a digital twin of the road network infrastructure, and then, artificially improve the resolution of the optical data through that AI process. And that led us to compute with pretty high-end performance, so more than 80% accuracy, the pavement index and the quality index of the road network.
Thank you. Yeah, I think as you talked about, having SAR data is super helpful as well because you can use SAR to see through clouds. You're not depending on daylight or sunlight. It's an active sensor, so you can use it for a broader use case. But as with all geospatial use cases, you need to overlay multiple data sets to really pull the insights out. It'd be great to understand the architecture a little more and the services that we utilize to establish or to build enough of a data set to be able to make decisions. So would you mind walking us through the architecture diagram and sort of talking about the different services that we utilized?
Yeah, sure. So we touched a bit the different types of data that we use for the projects. It's a big data project, so it's massive in terms of data streams and data storage. So obviously the first service that we've leveraged for that application, which is also the underlying structure of our software platform, is Object Storage S3. And that gives us everything we need, for data availability, accessibility, and performance. And also, the fact that it's elastic, gives us ways to scale the application quite easily. So that's the first block. And then I did not mention that, but the platform and also the application, they rely on a microservice architecture. So we use EKS, which is a Kubernetes managed solution, to orchestrate all the Dockerized applications that run to make those predictions. And then, from a logging perspective, we use I think it's CloudWatch for monitoring and logging, and we use also a tool for threat detection called GuardDuty. So all of that packed together into the application and connected through APIs to what I mentioned before, the open registry, the open data registry on AWS.
Absolutely, and there's so much data available on there. If anybody wants to have a talk about the Open Data Registry, come grab me afterwards. I'm a big advocate for it. Been using it since very early on in my career, and it is so powerful at enabling our customers to be able to access data that is already stored in S3. You don't need to recreate the wheel and re-download a load of those open data sets and have to pay for the storage. So it's really helped to change how we approach this use case. And you're right, we use CloudTrail and CloudWatch in reality to help provide that monitoring layer. Okay, so let's go to our next poll. I think it's a great time to do this. So next question for you, if you want to get your phones out, is how much data would be required to run this analysis on a country the size of Mexico? Can either of you remember which one? The volume?
I don't know.
It was a lot.
I didn't do the work.
So the alternative question is, can you remember the costs of your S3 storage?
No, I don't remember actually. But while you guys are working on the correct answer, which I think I know, but I'm not sure. We'll see in a second. I can talk through, the issues also from a data perspective of managing such a project. And if we cover more the open source database type of data, we work with different features, different types of formats. So if you ever run a big data project, those are the things that you need to be conscious about, how you can convert all of these different data formats into one single system representation, so all of your data can talk the same language. And this is highly critical for such analysis. Also, I was mentioning, as we use different type of databases, the features and attributes that are attached to road sections in some cases are different. So we had to build heuristics in order to make sure that we would have the exact same amount of attributes coming from the different sources and be able to merge all of that together. So, we touched a lot about AI, and we're going to cover that a bit later. But don't forget also that in a big data project like that, there is a pre-processing phase of the data that's really important. So you can basically create a common ground that would then be used for the analysis.
So this is really where you utilized EKS, is to do all of that processing to bring the data sets in line and to start pulling out the analysis using machine learning models. That's amazing, thank you. Okay, do you want to bring up the poll answers? Do we have any answers in yet? How are we doing? Ah, there we go. 10 terabytes. You all did amazingly well. That is absolutely the right answer. I mean,
I knew it.
1 terabyte wasn't quite enough when we're talking geospatial data. Remote sensing data is quite often heavyweight and data hungry, I think, is probably the best way of wording this. Thank you for all not selecting 100 gigabytes. If there were ever a geospatial solution that just utilized 100 gigabytes, I would say we need to go back to the drawing board because the data output wouldn't be significant enough. It's like looking back at the size of memory disks that we had 10 years ago. It seems just comparatively very small now. Okay, so let's flip back to the slides. Thank you very much. And Baptiste, I'm really intrigued to understand, how did remote sensing help with this whole process? You've talked about having to, I don't know what the word is, having to join your geospatial data sets together and restructure and change the schemas and manipulate the data. So talk to me about how you utilized all the various different remote sensing data sets available and essentially created what was going to be the data that went into these machine learning models.
Yeah, sure. We talked about like how to pre-process all of that open source data. And so, as I said, we created a digital twin of the road infrastructure network from highways to very rural roads, okay? So now imagine you have that skeleton that do not really carry any information about the type of road or the condition of the road. So you need to build those attributes, and that's how we've used remote sensing data, again, through optical satellite data or SAR. And so to do that, we've basically connected our application to the API on the AWS Open Registry data and picked exactly the information what we needed from that data source to bring the pixels that we needed to analyze to carry the analysis. And so I'm going to go a little bit into like technical elements, but imagine that all of that data is available at like as a grid for the entire planet, okay? So since we had that skeleton that represents the road network, we were able to ask the API to go and pick within that grid all the tiles that were superposed to the road network. And we did that both for the optical imagery and for the SAR imagery. Obviously, you have to be mindful of data transfer and storage costs. So we built an analytic to be able to do that in the most efficient way. And after that process, so basically downloading all the tiles from the registry, we would what we call mask the data and remove every pixel on those satellite tiles that would be useless for the analysis. Again, to be mindful of future processing costs, right? And then imagine that step as a filtering process of your raw data. And so what we then had was a network model enriched with the right amount of pixels to conduct our machine learning analysis.
Beautiful. And having access to data on the open data registry is really helpful as well, because that's all stored as cloud-optimized GeoTIFF. So it's already quite compressed, but when you open the file, you're not opening the entire file, which makes it easier for your machine learning models to be able to interact with the data. The header is at the top, so the solution is able to just identify where within each file as well it needs to open specific pixels, which helps when we're thinking about these solutions. Compression and data formats is really helpful to work through as well. It optimizes the speed at which machine learning processes run. So what did the training process look like? So you've got the data in, you've got your vector data, you've got your raster data, you've stored it, you're putting it through EKS, through containers, and running machine learning model. But can you talk to us more about how you trained the model and how you inferred on the data itself?
So yeah, the machine learning process was kind of like the last step of the whole process. What we used to predict the type of pavement and the condition of the road was boosted tree models. So what it is, it's actually almost like a decision tree, you have different layers of analysis, and each layer corresponds to a direction that the algorithm goes to, And what's interesting with that kind of approach is that every layer looks for different types of attributes, so kind of like remove the risk of being inaccurate. So see that as lots of filtering layers that the algorithm uses to navigate through the data set and find the right output. So we've used that kind of algorithm. The downside of that kind of algorithm is that it's processing heavy, you know. So one of the challenges we had to work on was keep the cost low for Aiga to be happy, and then for that we've leveraged the EC2 Spot instance that kind of gave us access to super heavy computing power at a very reasonable cost. Okay. The other problem that we had to solve was working on the heterogeneity of the data sources. So it's quite unusual to run an ML model with data from different formats. So using that boosted tree model, we had to add to it a feature extraction algorithm that would actually transform all of that heterogeneous data into something that the algorithm could compute together. And the challenge of that is what we've talked to before, like how you assemble all of those data sets to make the best prediction at the end. I'll just finish on how we manage the different workloads. You picked it right. You know, we're talking about 10 terabytes of data. There are lots of processes in the background for pre-processing the data, but also run the machine learning algorithm. And to enhance those workloads and make sure that everything was running smoothly, EKS was the main driver of that, because it automatically, you know, balances the workloads and optimizes them as the data flow is flowing. So all of that made us quite happy, and today the solution is quite scalable.
Brilliant, thank you. So how did you validate that what you were doing was successful? What was the approach to essentially taking the data that Baptiste was then giving you, Aiga, and for you to say, yeah, I have confidence in this process and it's been successful?
So, like I mentioned, one of the nice things about the output is also knowing where there was a higher certainty of the prediction and where it was lower. So, in certain parts of the network in Mexico, for instance, we were not as sure that the model was performing correctly, and so it was very useful for us to then, when we communicate these results to our client governments in Mexico, to be able to tell them, you know, these are the roads where we think you should still do a ground survey to really know what's going on. But the one key part of the whole process was finding good ground truth data, and it was very hard. So we used ground truth information in two parts of the whole process. So the first one was to build the model. So basically, we gathered ground truth data from various different contexts, from South Africa, Australia, Maryland, kind of like a very diverse mix of contexts to be able to get to something that would be close to what we were looking for, but not overfit the model. And then at the validation stage, we also use mapillary data and some high-resolution imagery to basically zoom in the network in Peru and understand if the model was correctly predicting.
So compare the outcome of the model to the sort of higher quality data.
Exactly.
But if we were to get that higher quality data and feed that into the model originally, the costs would have been exponential.
Exactly. And even though we have the Peruvian government, for instance, collects road network data, it was really not, we couldn't consider it to be kind of the truth because it had been collected over 20 years and we had no idea, you know, what each of those segments, when each of those segments had been surveyed, so we couldn't consider that to be the ground truth.
So I couldn't trust the accuracy. Gotcha. So another polling question, get the phones at the ready. So how long was the road network that was analyzed by the application? And the answer will be in kilometers. So essentially, for all of the data in Peru, how long was that road network in total that was analyzed?
And I gave away the answer earlier.
I know, you did give away the answer, yeah.
And just on the size of the network while you were picking your answer, the one cool thing that was basically we found that compared to, let's say, single open source databases, which we usually use at the World Bank, like OpenStreetMaps, this process was able to pick up significantly more roads by combining several different data sets together, especially in the very rural areas. I think we were able to find something like 100,000 more kilometers of roads. So just to give a sense.
That's really interesting. I think that happens everywhere. If you take one data set that's paid for, another open source one, and another open source one, it's creating a single source of truth almost, isn't it? Okay, let's move over to the poll answers. Very good. Well, you can enlighten us. Is that the correct amount?
I think it is the first. Yes.
Yeah, 52,000.
Nice. No, 5.2 million.
Oh, God, blimey,
520,000 kilometers.
Thank you.
That is the right answer.
I've missed off a zero. Yes, absolutely. Thank you. So it is a lot of data. It's a huge amount of data. Although we've got 45 to 50% people are on the edge. But ultimately, none of you thought it was a small amount, which is probably a good thing because we've given you the answer already. Okay, so what's next? What are the next steps? Baptiste, how are you going to progress this solution? And are you going to continue to iterate on it? Or is that it? Are you done and dusted? What's the process look like now, Baptiste?
So from our perspective, there are three types of advancements that we can bring to that type of project. So we did not touch that point, but what's also critical for big data project and the type of software that we're building is it takes into account a pretty big component, that's time. And bringing time series analytics to this kind of analysis is going to be really interesting. To give you a sense of what it means, the constellations of satellites that we are talking about, they collect new images almost every day on Earth. And that gives you a unique knowledge on how things can change over time. And basically, by stacking new information on our pre-existing network model, we'll be able to assess, the variations between yesterday and today, and also measure where degradations happen. And that will be super helpful in terms of planning better where the next round of investments should happen in order to compensate for those variations, right? So this is the first angle. Then what we've started to do, and this is a project we did with the World Bank in Tunisia, is add to the mix. So we talked about open source geospatial data, satellite data, but we're adding now to the mix precipitation data, weather information, along with topographic information to understand where we have areas of encroachment between water flooding and the road network. And using the condition of the roads, the type of roads, but also the geometry of the roads, we are capable of predicting where the network is the more inclined to be destroyed by a climate event. And in the context of climate change, having that dynamic approach and understand the pressure that the climate has on critical infrastructure is really important and goes, by the way, along with the World Bank new vision and strategy, right? And finally, in terms of technology, what we are thinking of doing is rely on SageMaker Geospatial to embed all the machine learning process within the application to make it more seamless and even more scalable. So those are the three angles that we are working on. And yeah.
Brilliant, thank you. It'd be really interesting as well, wouldn't it, to be able to rerun the process in the future and to be able to assess the success of the investments and identify, if you take the two data sets and do a change detection, essentially, how successful, how much road network has been improved through the investment. So that's really interesting. I guess, same question. What's the future look like for World Bank and how you move forwards with this project?
So I think it's kind of what Baptiste already was saying. It's that we can consider this to be like a basis on which we can build in the future as we have new questions that we want to answer, as we have new data that we want to add to the mix. So climate is one. Another type of information we are considering analyzing in some countries is to try to predict road safety issues on roads based on their geometry, based on presence of vegetation, many things. So that's another kind of question that we're interested in helping answer in several countries. And then, again, like Baptiste was mentioning, the time series component. So World Bank the World Bank typical project takes something like 5 years to implement, and ideally we would be able to use this kind of information to also track the implementation process or progress. So in some countries the ground presence is dangerous or impossible, and so remote monitoring of progress of project implementation could also be another application. And then kind of over the long run, we would rerun the process a few years and be able to identify statistical impacts, So like I mentioned in the introduction, we don't build roads just to build roads, but to actually help development outcomes. And so having kind of a repeated assessment over several years would be really useful for us to be able to have robust conclusions of what has been the impact on poverty, on human capital, on market access, et cetera. And so those, just to reinforce the points that were made earlier.
Amazing. So not only just understanding has that investment directly resulted in improving road quality, because those original roads will no longer be categorized as needing development, but also how has that actually impacted quality of life for those areas and those communities?
Yeah, and so having a solution that is very affordable at the scale of a country is really key for us to be able to use this as a decision-making tool, as kind of a knowledge tool, so that we can repeat the work every few years, let's say.
Incredible. And adding the precipitation data too is great, because then it allows governments to be able to decide what materials they're going to utilize to make those roads more climate resilient. So fabulous. Thank you so much for sitting and talking through the solution with us and diving deep into the different elements of the data and the analysis and the services that were used and the impact that's going to be had over time. So it's been wonderful sitting and talking to you. Thank you so much for coming here with us. And if anybody has any further questions, then come grab us afterwards. We're not taking Q&A today, but come grab each of us individually once we finish the session. And I'm going to leave you with some parting QR codes. Thank you for flipping back to the slides. So we have, in the last week, just published a blog post about this story and the work that we've been doing together. This is the first QR code. Please go take a look, have a read. There's the architecture on there, information about the services, and it's been an absolute joy working with you on this solution. We also have a link to our aerospace and satellite industry business unit page, which is the part of the organization that I'm sat in AWS, and Alteia and World Bank's web pages and blogs. So go have a look, learn more. Please feel free to grab us and ask any follow-up questions when we're off the stage. And it's been brilliant working on this. I've gained a huge sense of enjoyment, so thank you.
Thank you, everyone.